Hello and welcome back to another module of McGill Academy's tutorials. In this particular module, I'm going to be going over all of the finishing tools and patterning tools up here. So we've got Bob again. From the last video, Bob's changed a bit. He's going through a bit of an identity crisis at the moment, but that's okay. I'm going to use the Fillet tool on him. And similar to the Sketch Fillet tool, what you can do is you can essentially round out any corners or edges that you have and assign a particular radius to that fillet. So in this case we have a 0.1 inch fillet, but if you'd like, what we could do is we could make it larger, a 1 inch fillet. And there's also different types of fillets as well. You should choose one that's best to your interest or suits your project's purposes the most, but this tool is fairly straightforward to use. You press OK, and voila, Bob has now turned into a piece of toast. Very nice. Now, say you don't like toast. What's the next best option? Well, we could use a chamfer. So if you click on each of these edges, you'll notice that we're using the distance angle type of chamfer, where pretty much we give the computer a set distance across from the start of the chamfer to the edge of the object, and we give it an angle relative to this arrow here. Now, what we can do is we could augment that angle, and you'll notice that on one particular side you have a 60-30 degree triangle from the vertical axis, but on the other side you have a 30-60 degree triangle relative to the vertical axis. To change this, all you have to do is press this arrow, and it flips the direction. And you'll notice they are following the same trigonometric identities. Furthermore, you could also change the type of chamfer. So say the angle's not doing it for you, you could change both the distances. You could change pretty much the hypotenuse of the chamfer. It's entirely up to you. So I press OK there, and you'll notice it's slightly more boxy. It's not shaped like a piece of toast. Now, here at McGill Academy, we love Bob, and for that we're going to make more of him. So I'm going to click the linear pattern tool, synonymous to what we had when we were sketching, and I've already set a 10-inch space between each center of each iteration, and we're going to make 5 of them. Furthermore, I'm going to set a direction as the horizontal axis. Now, you may be tempted to select Bob or whatever you're making, and select the features and faces option to select your object. But I would recommend using the bodies tool instead. And the reason I say this is because of the fact that we have chamfers on this feature. If you were to just extrude something or use a revolved boss/base, it'd be perfectly fine to select the actual feature itself with the features and faces tool. But since we also have another feature compounded onto that chamfer, it's best to select the bodies option. Furthermore, you could also select a second direction. So we're going to apply the same spacing, but we're only going to have 2 instances, and you'll see why. We're going to actually have 10 of these different objects if I select this particular axis. There you go. So, as you see, we have 10 different versions of Bob. Very nice. As you can see, I've added the sketch. That's going to be for another one of our patterns, but you'll notice the same sort of logic applies for the circular pattern tool as well. So I click Bob, and I click an axis, so I want to revolve Bob around this horizontal axis. And we want the distance between each instance to be 90 degrees, and we want 4 of them. So 4 times 90 is 360, and you'll notice, boom, we have 4 instances of Bob. A nice little thing you can do is also skip one of these instances as well. So what you do is you drag, and you'll notice we don't need this particular part of the pattern. This is particularly useful if you want to make something that isn't quite symmetric or doesn't fit the circular pattern profile that it normally give you. As well, we can apply a curve-driven pattern, which is what this arc should be used for. So you click a curve, I'm going to add 5 instances as well, and they're all going to be about 5 inches apart from one another. And we select a body. I'm going to add Bob. As you can see, along this curve, it'll propagate Bob's pattern. Again, it's a pretty cool tool. Again, different people have different uses for it. It's not something I use too regularly, but it's an interesting tool regardless. As well, for more patterning, what we could use is the sketch-driven pattern tool. So you'll notice all these points here, and essentially if I click these points, and since they're all part of the same sketch, if you click one, you'll select all of them. And if I click Bob here, you'll notice that Bob is being propagated anywhere that there's a point in the sketch. So if we press OK, it'll look like this. And I've chosen these points at random, but essentially what I've done is I'll edit the sketch, and pretty much you could set a point anywhere you'd like. So we could add one here, 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 and then if we go back into our sketch-driven pattern and click that, and go here and click Bob, boom. It's as easy as that. Next up, we have the table-driven pattern. So the table-driven pattern is especially good for those of you who are a bit more analytical in the way you pattern your objects. So it'll ask for a body to copy or a feature and face, a coordinate system, and values for each instance. And essentially what you have to do is put in your own coordinate system here. So I'm going to base it off our vertex here. This is another form of reference geometry. And I'm going to go into our table-driven pattern and select that coordinate system. It's already selected. And put that there. And what this will allow me to do, as you can see here, is we can essentially change how far each instance goes. So say if I want this to go 5 inches, and we want it to go 5 inches in the Y dimension, we can do that. If we want another instance, make that go 10 inches, and it goes 10 inches as well, we can do that. And if we press OK, it will do that for us. So again, that particular patterning tool is better for those of you who want to customize how far each object goes. Furthermore, we have the fill pattern tool. This is a bit of a more abstract tool to use, but essentially it's good for creating holes without having to use a linear pattern and extruded cut and go through all those steps. So what I'm going to do is I'm going to press create seed cut, so it'll create the holes for us rather than relying on a hole that we've made before. I'm going to select a direction, so I've created the sketch for that, and I'm going to create a boundary. So this is our fill boundary. And you'll notice it's already created a ton of instances for this particular pattern. I'm using this pattern because this is a more rectangular shape. I figured it'd work better. But I'm going to change the number of instances per side, as well as the diameter of each of these lads. So let's set it to 1 inch. 1 inch diameters, and we have to set margins as well. So I'm going to make it about 0.5 inches away. And actually, we'll make that 1 inch. And what you can do is, as you change the spacing between each of these patterns, you're reducing the number of instances required. So if I want more instances, I could press that, and this is within our allotted space. As well, if you take less instances, you'll notice it becomes much more defined, and say we're fine with that. There you go. It creates patterns like that. I'd suggest playing around with that tool a bit more. It's a bit difficult to sort of grasp in terms of a video. So what I've done here is I've created 2 separate objects with 2 separate sketches. So one is a singular rectangular sketch, and the other one is this sort of hut that I've created with chamfer. So if I click the variable pattern tool, you can click features to pattern. I want to make multiple of these guys, so I'm going to click boss extrude and the chamfer. And then I'm going to create a pattern table. Now, you'll notice I have these dimensions set up, and that was something I've done in the sketch. So if I go back to my sketch here and click edit, you'll notice I've already set dimensions with the smart dimension tool. And this is extremely important for using the variable pattern tool, because this is how you dictate how wide, how large, and where each object, each patterned instance is going to go. And I've labeled each dimension as well. So if you double click, you notice I've named this one Z. So yeah, it won't let me change that up because I've already put that in. But yeah, this is my X dimension, this is my width, and this is my height. I'm going to exit sketch and go back to our pattern. So I'm going to click those same features and create a pattern table. Now, what you want to do is you want to select each of these different dimensions. So I'm going to select my X, my Z, my height, and my width. As well, I'm going to select my chamfer as well. So this dictates how high our chamfer is going to be, the vertical height of the chamfer. And what you can do now is add instances. So I'm going to say I'm going to add 5 instances here. And if you've ever used Excel before, this is going to be fairly intuitive. But if not, I could show you how. Say this is our X direction, and we want to create a couple of different objects along the X-axis. So what I'm going to do is I'm going to make the next one, we'll say 2 inches. Oh, whoops. 2 inches relative to our origin. So our origin is going to be the left-hand side here. Now what you can do is you can drag your mouse and select these 2, and then click that little icon in the bottom corner and drag all the way down, and it will maintain your pattern the way you need it to be. And if we update our preview, you'll see we've made multiple of these guys. It's pretty cool. Furthermore, say I want to make 6 more instances. Oh, whoops. So you unclick this and put 6 more instances there and start at the 0.5 again. We want this to follow the same pattern, so I'll drag this down and do the same thing. We want this next row underneath to be, we'll say, 2.5 inches away from the top. So what I'm going to do is I'm just going to drag that singular cell all the way down. And if I update the preview, it will show up like so. But say that's not good enough, and what we want to do is actually augment the height for each of these guys. Well, we could do that. We could press 2, bring that all the way down, and you'll notice they're all actually a little bit longer. Furthermore, we could also change the size of our chamfer as well. So if I say I want this to only be 0.1 inches from here on, and update that, our chamfer is changed as well. So if I press OK and press OK there, you'll notice we have different objects in different positions, and this is the freedom that the variable pattern tool gives you that perhaps the table-driven pattern wouldn't let you. The table-driven pattern only lets you choose the X and Y axis, or the X and Y coordinates of each of your instances, rather than actually changing all the different dimensions within them. So this is particularly good if you have to make a whole bunch of different copies of something similar that has slightly different dimensions. Next up, we're going to talk about the rib tool. So what I've done is I've created this sort of L-shaped model here, based off of 2 extrusions, and I've placed a plane right in the middle of this top component here, or in the midpoint of this whole component. And what the rib tool is going to allow us to do is to actually make a support between these 2 faces. Now what I'm going to do is I'm going to just make a simple sketch from a line going from one corner to the corner you want your support to end at. So we'll press exit there, and you'll notice it goes right along the middle. Perfect. Now we'll go into features, press rib, and you'll notice since the sketch is already selected, it automatically selects it again. So as you can see, the rib is actually going to be 1.5 inches thick according to this particular model. And currently the material side is on the wrong side. We need to flip that. And the logic behind that is you have to imagine it's almost going to be like a triangular block going down onto this bottom portion of this L section. So if we press OK, you'll notice we'll have this wedge of sorts. So this will save you a lot of time rather than having to, keep extruding or keep using sweeps to create random supports. It'll automatically detect where to end. Furthermore, you could also chamfer it. So if you draft, you could add a bit of a slope, as you see. Again, it depends entirely on your purposes, but usually that simple triangular wedge should be fine. For our next tool, which is a little more simple to use, we'll draft this block I've created. So what you need to do is select a face or a direction of pull, and now you need to select a feature face. So this is where your draft is going to take place. Now you'll notice you'll get two different results if you change the direction of this arrow. If you apply the draft this way, you'll notice it'll actually add material for your draft. And the rationale behind that is it's sort of pulling it towards that direction. It's a bit hard to describe, but you'll notice the difference if you go through the other side. So if I reverse this direction and click the same option and press apply, it removes material. So again, see what works best for you. Usually it makes more sense to remove the material, like I've done so here. In addition, we also have the shell tool. So the shell tool, if I click a face here and show the preview, you'll notice it does exactly what the name insinuates. If you augment the thickness here, this is essentially the thickness of what's left of each of these sides. So as you reduce it, you're going to have less and less material left. So if I press OK, we have cut within our model. Again, this is a very easy way of avoiding an extruded cut. Furthermore, you could also shell outward, and this value would actually change. There you go. So what's left is the original extrusion of your model. Now, I'm going to talk about the wrap tool for a little bit. So I've got this cylinder right here. It's got a hole in the middle, and the outer radius is 3 inches. I've done calculations for the circumference. You need to do that for this particular tool, and it's going to be about 18.84 inches. And I've set this reference plane as a basis for a sketch. Now, what I'm going to do is I'm going to make a sketch on here and select the corner of this particular cylinder. Oh, whoops, my bad. Select the corner and go throughout here. That should be adequate. And mention it, make it 18.84 inches. Perfectly fine. Now, what I'm going to do is I'm just going to create a random design, and you'll see how this takes shape once we actually apply it. And that should be adequate. That is fine. Now, I'm going to trim 1/2 of the contours, and you'll see why. Essentially, the wrap tool, what it does is it wraps this design around, if you can imagine. It wraps it all around the edge of this cylinder, and the side that's enclosed is the side that will stay. Anything below this particular wrap design here will be deleted. And we'll see that in fruition when we go into Features, press Wrap, and click the face of this sketch. You see, we've already got a preview of some sort. Now, I've selected the Emboss Wrap. That's the standard way to go, as well as an analytical wrap method. You could also change the thickness. So the thickness dictates how far in your wrap's going to go. So let's make this about 0.5 inches. And if we press OK, this is what we're left with. This is particularly good if you want to make any couplers or washer designs. It's really up to you. Next up, we've got the Intersect tool. So the purpose of this tool is essentially to take one solid body like this, and what it will do is by placing a plane or any form of infinitesimal geometry within this object, you can pretty much split it up into however many pieces you'd like. So what I'm going to do here is I am first going to center this, and I'm going to create a sketch. Now in our sketch, what I'm going to do is I'm just going to go from one side and make a random arbitrary pattern. Doesn't really need to be anything that fancy. There we go, that should be adequate. And voila, there we go. I'm going to insert a surface and extrude. So a surface, you may not be using it much during your time CADing because of the fact that it's generally mostly used for stuff like, creating sheet metal or body panels. It's very difficult to work with the formatting, and we'll go over that in a later module regarding file conventions. But for now, this will help us use the intersect tool. So I've pressed through all, so it'll go to the edge of the cylinder, and we'll press OK. Now, what I'm going to do is I'm going to press the intersect tool. It's already selected the surface, and I'm going to select the boss, and you press intersect. Now you'll notice this is split up in one region and another region. What I've done is I've essentially removed them by clicking them. And what you can do is you can exclude the regions by clicking them right here. So say I don't like this bottom region, I could take it out, press OK, and there we go. This is all that's left. And if I hide this surface extrude, this is all that's left of our cylinder. Furthermore, there's a lot more you could do, especially with the mirror tool. Now, if we want to use the mirror tool, all you have to do is press mirror, and since we use the intersect tool, this isn't technically a feature, this is going to be a body. If you click features, it'll actually include what we had before. So if you click bodies and your mirror face plane, and make sure to unclick your merge solids, you'll be able to mirror your object. It works the exact same as it would with sketching. And that pretty much wraps up everything regarding featuring. If you missed anything, be sure to check out our previous videos. If not, we'll see you in the next video, which covers DFM. Thank you.